Funding for NOVA is provided by Prime Computer, supplying integrated computer solutions to the world's manufacturing, commercial, technical, and scientific marketplaces. And the Johnson & Johnson family of companies, supplying healthcare products worldwide. Major funding for NOVA is provided by this station and other public television stations nationwide.
The night sky has always drawn human vision beyond the bounds of Earth. 2,000 stars, occasional comets, and 5 planets are visible to the naked eye. These have defined the universe since before recorded history. No other planets were known until amateur astronomer William Herschel built a powerful telescope in the basement of his house in Bath, England. In March of 1781, while studying the skies from his backyard, he observed a previously unknown object in the heavens. It was a landmark in astronomy. Herschel had discovered a new planet. We now call it Uranus. 200 years later, we still know almost nothing about it. It is nearly 2 billion miles from Earth and tipped on its side. 5 dark moons circle the planet. The smallest inner moon was only discovered in 1948. In 1984, this picture was made through a powerful telescope and then enhanced by computer. It confirmed the 1977 discovery that Uranus has a system of faint, very narrow rings, seen here girdling the planet. Uranus might have remained unknown and mysterious, except for Voyager 2. This unmanned little spacecraft would fly within 50,000 miles of the planet in January 1986. It would send back images and information that were absolutely unobtainable from Earth. This historic encounter was made possible by a rare coincidence of interplanetary geometry. The 9 planets of our solar system revolve around the sun at vastly different rates. But every 175 years, the orbits of the outer planets, Jupiter, Saturn, Uranus, and Neptune, line up, so that theoretically at least, a spacecraft from Earth can visit each one in turn. This rare alignment occurred in 1977. After 5.5 years of preparation, NASA's Jet Propulsion Laboratory planned to launch 2 identical spacecraft, Voyager 1 and Voyager 2. Both would fly toward Jupiter. Then on to Saturn. At Saturn, Voyager 1 would be flung upwards out of the solar system. But if it were possible, if the spacecraft could still function, Voyager 2 would fly on alone until it reached Uranus. Finally, Voyager 2 would continue on to its last planetary rendezvous with Neptune and onto interstellar space. The Titan Centaur rocket that carried Voyager 2 was launched from Cape Canaveral. Its 3 million pounds of thrust set Voyager, barely heavier than an automobile, on course at 45,000 miles per hour toward the outer reaches of the solar system. Voyager, a marvel of engineering design, reached its first objective, Jupiter, in 1979. It relayed to JPL thousands of surprising pictures of the immense planet. Then, like a slingshot, Jupiter's enormous gravity sent the spacecraft on toward its next goal, Saturn. Voyager sent back more than 15,000 images of the majestic ringed planet. The sturdy spacecraft was then headed on toward Uranus. But there were fundamental problems that JPL scientists and engineers needed to solve before the scheduled encounter 4 years later. Voyager's computers have limited memory. The Uranus encounter would severely tax their capacity. Uranus is so far from the light of the sun that photographing there would be like taking pictures in a ballpark lit by a birthday candle. And because Voyager would be nearly 2 billion miles from Earth, its already faint radio signal would be very difficult to receive. So from Pasadena, the JPL team drastically reprogrammed Voyager until it was effectively a different spacecraft. First, they activated one of Voyager's 3 backup computers. It reduced the amount of information that needed to be sent back. Then, to cope with the darkness, they developed a system of picture making called image motion compensation. It eliminated the blur that would have resulted from the long exposures needed at gloomy Uranus. Voyager's cameras remained fixed while the spacecraft swung gently to hold the image in focus as it sped by. Finally, to capture Voyager's faint radio signal, JPL electronically linked its radio antennas in Madrid, in the Mojave Desert at Goldstone, California, and in Canberra, Australia. They made, in effect, a single great ear, listening to Voyager's 20-watt signal 2 billion miles away. Australia's Great Parkes radio telescope was added to triple NASA's receiving capabilities. By November 1985, the newly reprogrammed Voyager was sending sharp, clear pictures of Uranus back to JPL's Pasadena complex. The vast Voyager team of 300 scientists and support staff, some of whom had been working together on Voyager for 14 years, geared up in anticipation of the January '86 flyby of the mysterious blue planet. Then, only 4 days before Voyager reached its closest encounter with Uranus, the images coming back from the spacecraft deteriorated in quality. They were degraded by a pattern of horizontal bars. Voyager's imaging team knew that all the close-up pictures of Uranus and its moons would be compromised unless the problem was found and repaired immediately. Engineers hoped it was a problem with the receiving equipment, but they discovered it was in the spacecraft itself, a physical failure of the computer memory.
Oh, when I got home from Disneyland, where I'd been with the grandkids, my wife said somebody called and there was a problem on the spacecraft. So I came in about 10 o'clock.
They had concluded pretty firmly that it wasn't a ground problem. In other words, ground software or ground communications.
Even if they could find the problem, it would still take 2 hours and 45 minutes for corrections traveling at the speed of light to reach Voyager, 2 billion miles away. Time was running out. These two computer programmers hunted all night through the volumes of information generated by Voyager's onboard computers, trying to find the exact location of the failure.
That's cell 453. 453, we found it.
When it was built, Voyager was the most advanced spacecraft ever. But now its computers are aging, and they suffer from an electronic form of dementia where single cells can fail and cause instructions to be misread or scrambled. That's what had happened. Programmers sent up a new sequence of commands which simply detoured information around the faulty location. And the new instructions got there before the most critical time, closest approach. JPL scientists learned more about Uranus in that 8-hour period than had been learned in the 205 years since its discovery. Voyager sent back over 7,000 images. Some yielded up their information immediately. Others may take 5 or 10 years to analyze. Here is what Voyager saw. The planet remained mysterious, even at close range. An enormous hazy blue ball. Time-lapse pictures shown here at 40,000 times normal speed showed how Uranus looked with its moons orbiting around it. Voyager's cameras used filters of red, green, and blue to enhance the planet's color and detail. But even enhanced, Voyager's pictures showed that Uranus is remarkably featureless. A 5,000-mile thick gaseous atmosphere enshrouds the planet. Below it is a 7,000-mile layer of superheated water at 8,000 degrees Fahrenheit. At the very center, there may be a molten rocky core. Uranus is a giant gas ball in space, made up of helium, hydrogen, methane, water, and ammonia. Nearly 4 Earths could fit across its diameter, yet there is no solid surface at all, no place to stand. And Uranus's orientation to the sun is truly bizarre.
Let me use this orange to tell you about Uranus. Uranus is different from the other planets because it's tipped on its side. Earth spins more or less straight up and down, which means that the sunlight is more or less falling on the equator and less on the pole. But Uranus is spinning on its side, which means that the sunlight is directly overhead at the pole and is exclusively falling on this one hemisphere. Of course, the year on Uranus is about 80 Earth years, and so in about 20 years, the orientation will change and the sunlight will be more or less overhead on the equator.
This schematic animation shows Voyager's point of view as it approached Uranus head-on to the pole. Due to this angle of approach, JPL's meteorologists were hoping to monitor continuously features that would reveal the nature of the Uranian weather system, its wind and cloud patterns, the length of its days.
One possibility was that we'd see a pattern in the clouds that we'd never seen before. I was actually betting, and a lot of other people were betting, that the pattern of circulation would be around the pole in spite of the pole being tipped over. In other words, it would be just a tipped version of Jupiter and Saturn. In any case, we were very anxious to see what the first Voyager images showed. Well, here they are. Basically, the first Voyager images showed nothing. We couldn't see clouds, patterns. It was featureless. On the other hand, there was a possibility that there were cloud features in these images, but they were too low contrast to be able to see them here. The solution was to stretch the contrast and see if there was something there. In fact, we stretched the contrast and played a sequence of images together so it would be a movie, and if anything was there, we'd see it move. Now, here's the results of our first attempt to make a movie of the cloud motions. And what you see here is not cloud features on Uranus, but mostly just the noise, the blemishes in the camera. These blemishes are actually dust specks on the lens, and we've never been bothered by them before because the things we were trying to look at were always so prominent. We, in fact, put together another movie when the spacecraft was closer, and finally, we saw something. You have to understand the perspective here. The spacecraft is approaching from over the pole, the planet is rotating counterclockwise, and the sun is more or less behind the spacecraft. And you see two significant things. First of all, faint bands, so that, in fact, Uranus is more or less a tipped-over version of Jupiter and Saturn. And secondly, you see small white features going around, and we can, in fact, clock these white features and measure wind speeds. These features are going around about every 16 or 17 hours.
Which is the length of a Uranian day. Color enhancement of the pictures made the overall pattern of the clouds and winds more visible. The belts and zones of atmospheric circulation appear as concentric circles. Uranus looks like an eerie eyeball in space. Because of the dense gaseous atmosphere that enshrouds the planet, Voyager's cameras concentrated on other major objects in the Uranian system, its rings and its moons. This is a view from Voyager, intensely computer-enhanced, of the outermost ring of Uranus called Epsilon. 9 narrow rings of Uranus were discovered by Earth-based astronomy in 1977. Starting with the outside Epsilon ring, they are called Delta, Gamma, Eta, Beta, Alpha, 4, 5, and 6. The rings, which are enhanced to look white here, are actually pitch black. To see them at all, the contrast of these pictures has been exaggerated to a level that makes the featureless background appear mottled, like an asphalt road. The rings themselves are several thousand miles apart and only a few miles wide. As this animation shows, planetary rings are not solid, but are made up of myriads of independently orbiting boulders, chunks of ice, and pebbles. All planetary rings are unstable and have a natural tendency to spread apart. They diffuse away out into space or are pulled in toward the planet. Well-defined rings, like those at Saturn and Uranus, have something keeping them in place. Based on what they had discovered at Saturn, JPL scientists expected to find 18 small shepherd moons at Uranus. Shepherds circle the planet within the ring plane, confining or deflecting material into rings and keeping it from escaping into space. But they only found 2 of them. This is one just outside the Epsilon ring, and this is the other that keeps the inner edge of Epsilon from drifting down into the planet's atmosphere. Voyager's pictures do not show what keeps the other rings in place. There may be shepherds too small to see. JPL scientists are still baffled. Voyager was programmed to photograph the ring plane not only on approach, but also from the side and then looking back toward the sun, after it had passed the planet. It was these views that produced the most startling discoveries.
This picture is of particular interest because in it Voyager made its first discovery of a ring that had not been observed from the ground. Just as the 9 known rings of Uranus were very narrow, so is this newly discovered ring, and it exists between the orbits of the 2 outermost rings, the delta ring and the broad epsilon ring. And you can see it here as a faint feature. In this very same geometry, when the spacecraft had imaged closer to the body of the planet than it did here, we discovered yet another ring, a much broader ring. This picture has a substantial amount of smear in it because of the fact that the spacecraft is basically plummeting through the ring plane at this point. But we see an unmistakable broad ring of material that exists, in fact, interior to the known rings, and this ring of material is about 2,000 kilometers wide. Really, our view of the Uranian ring system had not substantially changed by this point. We had expected to discover diffuse rings. We had expected to discover shepherding satellites. We were totally surprised by the next picture that you're about to see. In this remarkable photo, Voyager is in the shadow of the planet looking in the direction of the sun. And we see in this picture a level of detail and structure that nobody expected to see in the Uranian ring system.
Again, the clearly defined rings are seen with the sun behind the spacecraft camera on approach. Looking back into the sun, tiny specks of dust gleam in the light, revealing a vast sheet of material, an entire ring plane.
So what we're seeing when we look at this remarkable picture is a sheet of material, a very fine material, about 1 million times smaller or more than the largest particles which exist in the rings, and material which is easily victimized by magnetic field forces or collisions with neutral particles, and material which is falling inwards towards the planet. The rings are probably being eroded away right before our eyes.
By shining a radio beam through the rings back to Earth, Voyager discovered that the boulders that make up the rings are about 1 yard across. Tiny specks of dust are being ground off these rocks and orbit the planet between the well-defined rings as they spiral down into the planet itself. In a few 100 million years, these rings will have worn away to nothing. The narrow rings themselves contain patterns revealed for the first time by Voyager. The outer epsilon ring was photographed as light from a distant star flickered through it. Its intricate structure is very like the fine grooves of a phonograph record. Another Voyager discovery was completely unexpected. Orbiting just outside the rings are many previously unknown small moons. They are provisionally named after the year of their discovery. So, for example, the first moon of Uranus discovered in 1986 is called 1986 U1. 10 new moons have been discovered from the spacecraft images, bringing the total number of known moons to 15.
Before Voyager's arrival at Uranus, there were 5 large satellites known from Earth-based observations. Voyager presented a unique opportunity to search for small satellites. And in this frame, we can see the planet, the ring system, and several other small objects, some of which we know are stars, and one of the previously discovered small satellites. In this small image here is the current discovery, but it could be a camera blemish. Now, a camera blemish is something that repeats from frame to frame. It's an imperfection on the camera surface or a spot of dust. But we can catalog those because we have many frames. We can create a blemish catalog, and I can display that and in fact show that the candidate is in fact not a blemish, so therefore it remains a valid candidate. Now, the other thing I can do with my computer program here is to mark that position so that I can predict, if it is in fact in orbit, I can predict where it should move to in other frames. And now, having marked that location in this one frame, I can predict to another frame taken slightly later in time than the first frame, in which I calculated basically an orbit for that object, and predict where it should be just as I predict where other objects in the field should be. At that point, we have a scientific discovery of a new satellite of Uranus.
Only one of these newly discovered small satellites or moons, 1985 U1, was photographed close up. It is about 106 miles across and only barely round. At least one impact crater is visible, and its surface, though it gleams here, is very dark and somber. The moons of Uranus are named after sprites and spirits in English literature. Miranda, Ariel, Umbriel, Titania, and Oberon. Voyager was precisely programmed to photograph exact frames of each of the 5 minor moons. This computer animation shows the journey that Voyager took through their domain. All the moons are dark and unimaginably cold. At 300 degrees below zero, they are the coldest worlds yet seen by mankind. Even the largest of them, Titania, has no atmosphere, no life at all. But Voyager scientists hope to garner evidence from these desolate moons about how they formed and when. Perhaps from the moons would come clues about how Uranus itself became the strange, tilted planet we see today. Even after Voyager scientists had seen images of the planet and its rings, they had no idea what the moons would really look like. This dark, remote, and lonely realm would prove to be more baffling and perplexing than anyone could have expected. And Voyager's images of the moons, flawlessly executed, may raise more questions than they answer. This is Oberon, the outermost moon of Uranus, as it was actually photographed by Voyager. It is about 960 miles in diameter, only about half the size of Earth's moon. Like everything in the Uranian system, it is dark, gray, dingy, and gloomy. It has an enormous mountain-like object on the side, a half-mile high. This may be the central peak of a giant crater several hundred miles across. The rest of Oberon's surface is scarred with impacts. What might have caused the impact craters? And what can be learned from these pictures about the history of Uranus?
The type of thing that we're looking for in a picture like this is evidence for what the structure of the planet is like, what caused it to be like this. And what we see are craters which have bright rays running out from them across a darker surface, and then rather darker areas in the center of craters. And what type of thing could create that? One of the simplest models that we have, and probably a correct one for this moon, is that it results from a layered structure. We have dirty, very rock-rich material deep within the planet, and then a cleaner ice layer outside that, and then on top of that, a dirty debris layer, if you will. And so what we're seeing over most of the moon's surface is this dirty debris layer, and when a large crater punches through that, it spreads brighter ice out over the surface that creates the bright rays.
Voyager found that all the moons of Uranus are made up of rocks and ordinary ice. Over time, the heavier rock has coalesced into the interior. Most of the ice that covers it is quite clean, and the thin surface layer is sooty and dark. In Oberon's ancient past, it might often have been struck by comets or meteors, common events in the outer solar system. Such impacts would break through the outer crust of dark material. Deep craters would be gouged out, and then the clean white ice below would spread out onto the surface.
And then subsequent to that, we believe that we must have had some period of, if you will, volcanic filling in of the bottom of these craters with an even darker slurry of dark, possibly organic-rich material. And this is what you might call an archetypical Uranian moon. It's more or less what we expected to see from these things made of ice and rock.
Moving in toward Uranus, the next moon is Titania. The early low-resolution images of this moon looked very much like Oberon. It too is an impact-scarred ball of ice and rock about 1,000 miles in diameter. But the close-up views showed something quite extraordinary. Geologically, Titania is very different from Oberon. There are gigantic canyons and rifts visible on the surface. At some time in the past, even at temperatures of 300 degrees below zero, the surface of Titania expanded. Perhaps when the moon swelled as the ices within it melted and froze again.
An interesting hypothesis was that these bodies had a fair amount of methane ice and ammonia ice incorporated in them, in addition to ordinary water ice. This is reasonable for the outer solar system because the temperatures are so cold there. The things that we think of as normal gases at Earth conditions become ices at these very, very low temperatures. The presence of something like methane ice along with the water ice has two important possible consequences for these satellites. One is that its melting temperature is much lower than for pure ice. And that means that we may easily heat these things up to the temperatures where we get interesting geology going on. The other interesting point about methane ices is that when one takes them in the laboratory and irradiates them with charged particles, electrons, ultraviolet radiation, they become dark. You produce dark red hydrocarbon deposits from irradiating this ice. And we were more or less looking for this type of material when we went to the Uranian system. One of the ways in which we can test that hypothesis is by looking at the color of these objects. This is a colored picture of Titania. It doesn't look very different from a black and white picture. We can quantify that with the computer by looking at a profile or intensity trace across this picture, which shows us the intensities in the three different color bands that went into making up this picture. And what that shows is that indeed, Titania shows very little difference between the three different colors. So we're left with a problem here. Either the hypothesis is not right at all, or it needs to be modified.
The hypothesis was that Titania's dark surface was methane ice, darkened by the intense radiation of the zone in which it orbits. That radiation can actually be heard on a recording made by the spacecraft. But analysis of Voyager's images of Titania proved it wasn't methane. Another plausible theory is that Titania's inky surface is of truly ancient origin and is a dusting of leftover carbon from the creation of the planets. If it is carbon, then it is possible to simulate what the surface of Titania actually looks like.
We do have samples of rocks that come in from the beyond the Earth, extraterrestrial materials, which are very dark. This is a sample of the meteorite Allende, and it's dark because it does have a great degree of carbon in this dark matrix material here. Now, we can take in the laboratory and extract these carbon materials chemically, and that's been done for another meteorite. It's some of the darkest material known to man, and it comes from out in the solar system where we're looking at these things. Now, we can't actually fool around with this material because it's very precious for further studies, but we do, it turns out, have a good analog, ordinary lampblack, whose physical and chemical properties are quite similar to the meteorite extract. So we can perform a little experiment and see what we would expect to be going on if we, on the surface of one of these satellites, if we took ordinary ice and mixed it with some of this material for darkening it, for instance. Here we have a bucket of water ice at somewhat higher temperatures than we have on the Saturnian and Uranian satellite systems. We can just sprinkle a little bit of this lampblack in on top of it, and it doesn't take very much to make a surface exceedingly dark. Mix that up, and what one sees is a mixture of material that's not dissimilar to what perhaps might be actually on the surface of one of these things.
This, in all probability, is what icy titania would look like to a person standing on its surface, if such a thing were possible. Inside Titania's orbit is Umbriel. It is smaller than the two outer moons, only about 740 miles in diameter. Umbriel is the darkest of the 5 major moons. An enigmatic white donut shape is visible at the top of this picture on Umbriel's equator. Dark Umbriel appears to be scarred all over with impact craters, which suggests that it has changed little since its formation. The craters themselves may enable the Voyager scientists to find out how old the surface is. The solar system, including the Earth, Uranus, and all its moons, was made about 4.5 billion years ago, out of an enormous ring of material circling the sun. Gradually, this swirling ring condensed into planets and moons, which formed by sweeping up the smaller objects around them. The oldest surfaces in the solar system still show the scars from this process. They are covered with impact craters from this continuous bombardment. Even the Earth has a few craters. This one, Meteor Crater in Arizona, is about 1 mile across, and the impact happened only around 22,000 years ago. But weathering and other geological processes have wiped out most of the Earth's older craters. Voyager's images of Umbriel, however, show that its surface is saturated with craters. This indicates that the moon has undergone very little geological change since it was formed. So its surface is very old, older perhaps than that of any of the other moons of Uranus. The puzzling donut is probably a much more recent crater, which has not yet darkened to the color of the rest of Umbriel. Further in towards Uranus orbits the 4th large moon, Ariel. It is about the same size as Umbriel. Its surface is relatively bright, almost twice as bright as dark Umbriel. Ariel is scarred by a complicated pattern of fractures and rift valleys. Everywhere else, as these images show, Ariel is marked with evidence of geological activity that is difficult to explain according to any current theory of planetary geology.
We see fault systems that cross the surface in organized rectangular or linear patterns that transect one another. They look very much like graben, we call them on the Earth, in which a sliver of the crust breaks on a pair of planes and falls down into the Earth, very much like a doorstop going into a slot. The process that causes that is extension, stretching of a planet, and the planet is trying to increase its surface area. So one way is simply pull those faults apart and the wedge drops down, increasing the area.
The valleys of Ariel have smooth floors, unmarked by the fault lines that made the valleys themselves. To understand how curious this is, it is necessary to go back into Ariel's past. After the Great Bombardment, Ariel's surface expanded, perhaps as the ice froze, and it cracked in a crisscross pattern. Then some material, maybe ice or liquid slush, flowed into these valleys, filled them up, and gave them the appearance they have today. The process is very similar to some volcanic eruptions on the Earth. But where did the ice or slush come from?
If we trace back up these canyons, this common floor appears to be connected to another region up on the higher terrains on Ariel, and we can see a smooth region up in here. If we look a little farther, we see that it appears that this valley in here was breached. Material flowed out, partially buried in impact crater. We can still see half of it. It's fairly viscous or thick flow because it had to stand and retain a fairly sizable flow front right in this region. It flowed over the edge of this cliff on the edge of this canyon, muted the topography there, flowed on down through another notch, and then flooded the floors of these valleys. So some sort of volcanic activity had to occur on even Ariel. Here the temperatures are 70 degrees above absolute zero. Things like water ice and just about any other material that we find commonly would be solid beyond comprehension.
Ariel has another mystery. Snaking along the middle of some of the smooth-floored valleys are sinuous canyons. When the imaging team first saw these, some thought they might be river valleys, rather like this dramatic canyon on Earth.
Here we are at the Grand Falls of the Little Colorado River. It comes in here and goes on down in a sinuous path. And this sinuous valley looks much like the sinuous valleys we see on Ariel, one of the moons of Uranus. What's happened here is a complex story because we think this right angle is made by early faults. And then the river was carved, and because the rocks were broken by the fault, it made this right angle bend and followed the fault trace. The sinuosities are due to the meandering of the river. We have a complex intertwining of faulting, stream valley cutting, and lava flows that make this complicated geologic story. When we first saw the sinuous valleys on Ariel, the question was, could water have flowed on the surface there? That's not possible on Ariel. It's much too cold for surface water to flow, and there's no atmosphere. Here we are at a different kind of sinuous valley. This one is very different because, as you can see, we're at the foot of a volcanic mountain, and this was built by a fire fountain depositing little fragments of lava that chilled in the air and fell down, and then later a lava flow broke out at the base of it and flowed out in this direction. And as it flowed, it chilled on the margins, building these marginal levees. And the sinuous channel went down until the lava flow chilled and stopped flowing. The question is, what's the sinuous valley on Ariel? Is it cut by flowing water? We don't think so, because there are no tributaries or the other fine details that running water flowing makes. Is it a lava channel? It doesn't have these marginal levees like we see here. The only one left is fault valleys. That is, tectonism breaks the crust, allows material to drop down, and forms the sinuous valley. The big question is, how do we decide this kind of thing? When you see pictures of a planetary surface for the first time, first you have to look, not allow your prejudices of what you hope to see there blind you to what's really there. And second, to sort through all of the geologic processes that you're aware of, because each planet will be slightly different. And then to carefully compare what you see in the picture with what your memory is of all the other geologic processes that you've seen, and then try to come to the proper conclusion.
Even after the puzzling and mysterious pictures of the other 4 moons, no one at JPL was prepared for Miranda. It is the smallest of the major moons of Uranus, barely 300 miles across, and it is the closest to the planet itself. It is unlike any moon ever seen before, and is one of the most enigmatic objects in the solar system. Even from a distance, scientists could see this odd right-angled shape. Close up, Miranda looks bizarre, an unexpectedly complicated and exotic object in space. As the highest resolution pictures show, some of the surface is an ancient cratered landscape, much like the surface of Umbriel. Other parts are scored with gigantic swaths and grooves. Miranda seems to include all the landforms in the solar system rolled into one. One NASA scientist described it as a moon designed by a committee. Strange Miranda is not made of the same stuff all over. Here, a crater has exposed white material. In other places, craters have broken through to more of the same gray material that dusts the surface. This is the right angle that was seen earlier. Once they saw it up close, the imaging team called it the chevron. It is about 100 miles long. Most extraordinary of all, Voyager photographed a palisade of gigantic white cliffs of ice, the biggest ever seen.
It shows a fault which has broken the crust on what looks like a scissors fault, in which it's hinged back here and it breaks open like this. And the relief on that fault is of the order of 20 kilometers.
These cliffs on Earth, the Vermilion Cliffs of the Grand Canyon, are 1 kilometer high. Their scale can be judged from the size of the trees growing in the forest at the top. The cliffs on Miranda are over 24 times higher than these, twice the height of Mount Everest. This is a mosaic of Miranda, elongated because it is made up of all the pictures taken by Voyager as it sped by. The mosaic shows that the strange landforms on Miranda are confined only to certain places and seem to be superimposed on the much older cratered surface.
The first step was to try to classify things into groups that could be handled conceptually, or we could try to unravel the story of one particular type. And as an example, these 3 terrains look very different. One we referred to as the flapjack, and another one as the chevron, and then one we refer to as Circus Maximus because of this racetrack-looking affair that runs around the outside. First reaction, you might think those are very different. We did. But if you start to look carefully at the 3, you realize that they have some very, very common aspects. Well, first let's start out with the outer 2, the large ones, and I'll go here to a map. This is a map that's a composite of this mosaic plus earlier images. And here you see the Circus Maximus region and the Flapjack region have about the same overall shape and size. They're both about 250 kilometers end to end, and they both possess this quasi-rectangular shape with the rounded corners. They both possess an outer margin which runs around this rectangular pattern with the curved edges. You can see here and here. Also, looking at the chevron region, we can see some aspects that are very much like the other 2. These 3 are the same basic geologic phenomenon that is operated to different degrees.
The mystery that we want to solve for Miranda is how these extraordinary features are found just in some places and not all over the satellite. The secret to that may lie in the impact history of all of the satellites and of Miranda in particular. We can imagine that Miranda, at one point in time, was warm enough that the rocky parts and the icy parts were separated, the rock sinking to the middle and the ice to the outside. Let's imagine this beaker represents a portion of Miranda, the whole satellite being a round feature like this, with the ice having risen to the top and the rocks having settled to the center when Miranda was warm enough at one time for this separation to take place. Now, we know from study of the satellite surfaces and a calculation of the rates of cratering at different places within the satellite system that Miranda has probably been broken up perhaps a dozen times by very large impacts in the same time that the craters that we see on Oberon were formed. Now, if we imagine that the last time this happened, Miranda was smashed with a projectile, a comet nucleus, big enough to break the whole satellite apart, this nicely sorted arrangement of ice and rock would be distributed as debris that would go into orbit and would be mixed up in the orbit and spread out following the orbit of Miranda. Now, that debris won't remain there very long. It will want to collect back again into a satellite, rather quickly, as a matter of fact. But when it collects back in, the pieces that will fall into the satellite will come in different orders: icy chunks, rocky chunks. And so when we finish up, the final satellite will then be all mixed up and scrambled, looking quite different than it did at the outset. So we end up with a satellite then will look something like this. Now, of course, the satellite is not very happy in that state. The rocks do want to get back to the middle, and the ice wants to get to the outside. But it has to get warm enough for that to happen.
The heat generated by the tidal forces on the moon melted the ice. As the melting ice rose, it started cracking the surface with patterns of grooves. This happened only in certain places, probably above deep masses of ice, or where rock was resting near the surface and sank into the depths of the reassembled moon, causing the unusual patterns we see.
It's likely that all of these objects were blasted apart and reassembled multiple times during their accretion. So if some of these fault patterns were induced by those kinds of catastrophic events, it would have been a tremendous earth-shaking, Miranda-shaking event to be there.
But the major catastrophic event of the Uranian system is the one that knocked it sideways to the sun. Almost certainly, Uranus once orbited upright as the other planets do. Like a spinning gyroscope, a planetary system has its own stability. Its revolutions continue even if it is tipped over. It now seems that ferocious collisions between Uranus and one or more Earth-sized objects occurred and knocked the planet on its side. Even so, it continues to spin, but its pole, not its equator, faces the sun.
Where did these impacting bodies come from that pummeled the satellites of Uranus and probably tipped Uranus itself over on its side? To answer that question, we have to go back to the origin of the planets. And here we have a diagram showing the planetary region as we see it today, with the orbit of Neptune, Uranus, Saturn, Jupiter, Mars, and the orbit of the Earth and the close planets and the sun itself, just in this tiny region in the center. And all of these dots in this region out here represent a swarm of small bodies of ice and rock, out of which Uranus and Neptune accumulated. These bodies were perturbed by the growing planets. As they were accumulated into the planets, most of the objects actually were thrown out of the solar system, and only about 5% fell onto the planets themselves. One of these big impacts probably produced a spray off of Uranus and formed the satellites that we see. But the swarm of small bodies, which we call planetesimals, continued to buzz around the planets in this region for about 500 million years. And so long after the planets were formed, there was still an intense bombardment.
According to this theory, Uranus and its moons revolved upright as the other planets do. But early on in its history, a massive planetesimal struck the planet and violently tipped it over. Tidal forces disrupted the orbits of the moons, which destroyed each other in collisions. The debris settled into a wide new ring, which condensed into a fresh collection of moons, orbiting to match the tilted planet. Later on, other planetesimals from the same swarm reappeared periodically to smash the moons. The apparently random differences between the moons would be explained by their luck in escaping the shattering impacts of the planetesimals. Oberon, and especially Umbriel, seem from their old cratered surfaces to have escaped recent collisions. Ariel has a younger surface that shows signs of geological activity. It and Miranda were probably broken apart and reassembled many times over as chunks of primordial matter periodically smashed into them. What became of the planetesimals once they had bombarded these moons?
About 5% of these objects were actually accumulated to form the planets, and as they grew, they perturbed the rest of these small bodies into larger and larger orbits, and finally most of them were actually thrown completely out of the solar system. Somewhat less than 10% remain today in a huge cloud surrounding the sun, and as passing stars go through or near this cloud, they perturb a few of them which fall down toward the sun to the neighborhood of the Earth, and we see them as comets.
The realm of the planet Uranus is a world we now know something about, thanks to Voyager and NASA's team of scientists. 7,000 images from the Uranus encounter answered many basic questions about the distant seventh planet, the length of its day, its weather, its rings and moons. Voyager's success is a remarkable technological achievement, and its importance to space science will continue for many years.
Even though Voyager 2 is now an old spacecraft, it performed essentially flawlessly at Uranus. In fact, it performed better at Uranus than it had at Saturn because of some design changes that we've made along the way. And we expect that the spacecraft will perform equally well when we arrive at Neptune in August of 1989. Neptune is 3 billion miles from Earth, so we know even less about Neptune than we knew about Uranus. We do know that it's a planet about the same size as Uranus, and we, in fact, want to study the weather in that planetary atmosphere. We'd like to study the fragments of rings which have been discovered in orbit around Neptune, and we'd like to measure and detect whatever kind of a magnetic field Neptune might have. And finally, there is a major moon in orbit around Neptune called Triton, which is very intriguing because from Earth there is evidence that there may be methane, that is natural gas in a very tenuous atmosphere. There may well be lakes of liquid nitrogen on the surface. If so, Triton would be the most interesting object yet visited in the solar system.
This computer animation shows the Neptune encounter that will take place on the 24th of August, 1989, and the Triton flyby the next day. Voyager's encounter with Neptune will propel it out of the solar system and into deep space like its twin Voyager 1. At JPL, the engineers are now preparing for the Neptune encounter. Perhaps by the time Voyager reaches it, scientists will have worked through the full legacy of its exploration of Uranus. Pointing its camera backward toward the sun, Voyager sees mysterious Uranus recede into the distance.